In this video, we're going to look at a Leetcode problem called edit distance. So given two strings, word1, word2, we want to return the minimum number of operations required to convert word1 to word2. So we have the following three operations to do on a word, right? So we can insert a character, or we can delete a character, or we can replace a character. So you can see here we have two words. So we have those two words here. And then in this case, there are a total of three operations that we need to do. In this case, the minimum operations that we can do to transform this word to this word is 3. Basically, we transform horse to roars, and then we transform roars, right, by replacing H with R, and then we transform roars to rose by removing a character, and then lastly, we transform rose to Ross by removing the E, right? And then you can also see that if we can also have intention and execution, right? So if I want to transform this word to this word, I have the minimum operations it takes is 5. Basically, we first remove the T, then we replace the I with the E, and then we replace N with the X, and then replace N with a C, and then we insert the U, which is right here, which at the end will give us execution, right? So you can see that for each and every single move, we have 3 operations to choose, right? Either we can be able to remove, replace, insert, and there could also be a situation where we don't really move, where we don't do anything at all. So you can see that, let's say we have two strings, right? We have ABD and ADD, right? So if I want to transform this string to this string, I need to look at the last character. In this case, the last characters, they're all the same, right? So D and D, they're all the same. So in this case, I have 4 operations to choose. Either I do nothing, or I insert, or I delete, or I replace, right? And you can see that if I do those 3 operations, that takes 1 operation. If I do nothing, I take no operation at all, right? But they are the same. So in this case, I don't have to do anything, right? With those two characters, right? So what I can do is that I can try to find the minimum number of operation it takes to basically find the minimum number of operation it takes to make the remaining string of both strings, right, to be the same, right? So in this case, we have AD comparing with AB, right? So in this case, we have AB. We want to know the minimum number of operations it takes to transform to AD. And then in this case, you can see that we're basically breaking down to a sub problem, right? So in this case, we have another sub problem. And then in this case, we want to go from AB to AD. So in this case, we have 3 operations. So we know the last characters does not equal the same. So in this case, what we're going to do is we can be able to replace, or we can be able to delete, or we can be able to insert. So in this case, we want to know the minimum number of operations it takes to replace, the minimum operation it takes to delete, the minimum operation it takes to insert, right? So once we know that, we can be able to say, okay, well, in this case, replace seems to be an option, right? So in this case, if we replace, what's the minimum number of operation it take, right? For the remaining substring to be the same, right? In this case, and then if I delete, what's the minimum number of operations it takes to delete this character to make the remaining substring to be the same. For insert, if I insert a character, what's the minimum number of operations it takes to make the remaining substring to be the same. And then in this case, what's going to happen is that you can see that if I replace, I basically do 1 operation, right? So I replace B with a D, and then that's 1 operation, and that's it. If I delete, then in this case, basically, if I delete this B, then what's going to happen is that I have to continue to break the subproblem down, right? Because in this case, I'm deleting the B. I check to see if there is a D, right? I check to see if there's a D in the remaining substring. In this case, there is none, right? So basically, you can see that once we delete the B, we still need to check to see if there is a D in the substring, right? So that we can be able to go by character to complete the operation. And then in this case, if I go with insertion, I insert a D here, then in this case, I need to check the remaining substring, which is AB, right, with the remaining substring of this substring, right, which is basically A comparing with AB. So you can see that we're basically breaking the problem down to a smaller problem, and eventually we're basically just going to know the base problem, right, and then we can be able to use the solution of base problem to solve the parent subproblems, right? And then if we have an empty string, like if I have an A and I want to transform to AAD, in this case, I basically need to have 3 operations, right? Basically, I need to, so this is basically like the base case, right? Like we're trying to define the base case here. So if I have one string that's empty and I want to transform to this, it's basically I add 3 character. That's 3 operations, like 3 insertions, right? And if I have SA and I want to transform to empty string, that's also that's basically 2 operations, right? We basically delete 2 characters. So this is basically a base case. Another base case is that if we have 2 empty strings, then that means we basically have to do nothing, okay? We basically do nothing because there's nothing that we can do to transform 2 strings because they're already the same, right? So now let's take a look at an example, right? So how we can be able to, it doesn't matter how you're going to do it in using either top-down approach or bottom-up approach. Basically, we can be able to focus on just defining the base case. Once we define a base case, we define how we're going to solve the subproblem, and then we can be able to build our DP table, or you can do it in the top-down approach. It doesn't really matter, but we can be able to solve that using the same core concept, right? So the concept is just the same, just like I mentioned before. If we have an empty string, right? Again, the problem the problem is that we want to go from grab to cap, right? We want to know the minimum number of operations take to go from this string right here to this string. So in this case, what's going to happen is that we're going to have 2D array, and the columns, basically you can see the column represents grab, right? And then the rows that represents basically the designated string, right? So we want to go from this string to this string. So in this case, we know that so basically those 2 cells are empty, right? So if we have empty string, so in this case, if I want to transform this string right here to this string, is basically 0 operations, right? So, and then if I want to transform like, G to empty string, that's just 1 operation. Basically, I can delete, right? Just like the base case that I was talking about. If I have GR and I want to transform to empty string, that's the 2 operations right here, and so does the remaining strings as well, right? If I have GRA, then in this case, it takes 3 operations, right? Basically deleting those 3 characters to become an empty string. And then now let's take a look at this. So if I have an empty string, I want to transform to C. In this case, that I just need to insert a C, and that's 1 operation. If I have an empty string, I want to transform to CA, that's just 2 operations, right? Basically, I insert A, I insert C, that's 2 operations to go from empty string. And same thing for CAB, okay? So once we have the base case defined, what we're going to do is that we're going to start to use those solutions to solve our subproblems, right? So in this case, what does this cell mean? Basically, this cell means that if I have G and I want to transform to C, what's the minimum number of operation? So in this case, you can see that we basically know that they are not the same, right? So in this case, they're not the same, and then we want to transform this to this. So in this case, what's going to happen is that we need to perform those 3 operations, right? Because they're not the same. If they're the same, then pretty much we can do nothing. Like we can pretty much, if this is a C, what's the minimum number of operations it take to go from C to C, right? 0, right? But in this case, this is not. So what's going to happen is we're going to choose those 3 operations. But the thing is, we already computed that before, right? We know that from here, right? In this case, from this is basically delete because we're going from G to empty string. This is basically from empty string to a C. right, which is basically insertion. And this is basically replace, because once I replace G with a C, I need to know the minimum number of operations it takes to transform the remaining substring, which is basically empty string and empty string, right? Which is basically 0 number of operations. So that's why we have 0 there. So in this case, that's why I have just a small table, which represents, if I want to know the, in this case, the current number of operations it take to, right, in this case, to transform the current string, the string 1 to string 2, is going to be the minimum out of those 3 if they're not the same, right? So if they're the same, then it's basically 0 number of operations, right? Or in this case, yeah. Otherwise, we're going to find the minimum number of operations to take, right? So what's going to happen is we're basically just going to do that, right? So in this case, you can see the minimum is basically 0. I can basically replace G with a C, and that's basically 0 operation, right? But in this case, we're replacing it. So in this case, it's just going to be 1. So 0 plus 1, which is just 1. And then now we have GR, right? If I want to go from GR to C, okay? So in this case, if I want to go from GR to C, in this case, we know that they're not the same, right? In this case, R and C is not equal to each other. So in this case, if R and C does not equal to each other, basically, we're just going to see if we should just delete a character, right? In this case, delete character is 2 operations, right? So if I delete G, if I delete R, if I delete G, and then I add, basically delete R and then replace G with C, that's 2 operations, right? And then here you can see if I transform G to C, that's basically 1 operation, but it's basically replace, right? Basically, I insert a character, right? In this case, if I'm basically inserting a character, and then here is I basically replace a character, right? So basically, if I replace a character, I have to check the remaining substring, right? In this case, G with the remaining substring of C, because in this case, I replace R, right? R with a C, right? So, and then I basically have to check the remaining substring, which is basically G with the empty string, right? So that's why we have replace here, insert and delete. So the minimum out of those 3 is basically 1. So 1, we basically plus 1, which is basically 2, right? So 2 operations, which makes sense, right? We basically delete a G, replace R with a C, right? That makes sense. Okay, so and the same thing here. And then in this case, the minimum out of those 3 is 2. So 2 plus 1 is 3. Same thing with those 3. In this case, the minimum is 3 plus 1 is 4, right? Because they're not the same. And then same thing here is basically 1, right? So 1 plus 1, which is basically 2. And then here you can see we have the minimum, which is 1. 1 plus 1 is 2. Okay, so now if we met a situation where we have 2 characters are the same, so what do? We know that they're the same, right? So in this case, we don't really have to. In this case, we have GRA compared with CA. We know the last characters are the same, right? So then, just like I mentioned before, if they're the same, we don't have to worry about it. We can just do nothing, and then we can just check or find out the minimum number of operations to take for the remaining substring, which is something that we already did, right? Which is right here, right? Which is 2. So in this case, what's going to happen is we're just going to inherit from the previous pre-computed value, which is basically 2. Okay, so now A, B does not equal the same. The minimum out of those 3 is 2. 2 plus 1 is 3. Okay, so now in this case, we're on the last row. So basically G and B does not equal the same. Minimum out of those 3 is 2. 2 plus 1 is 3. So here, same thing. 2 plus 1 is 3. And then this one, same thing. 2 plus 1 is 3, right? Because in this case, 2 is the minimum out of those 3. And then once we get to the end, Okay, so you can see we also have B, right? So in this case, for B, in this case, we can pretty much just, in this case, grab, comparing it with cab. We know that B are the same, so we're comparing with the remaining characters, right? So we have grab and cab, right? But the thing is, we already computed that before, which is right here, right? Cab, or cab and grab, right? So in this case, 2 plus 1, just 2, right? We inherit it from the parent, which is basically the result here, right? So that basically gave us the answer, right? It makes sense because all we had to do is we just basically remove G and then replace R with a C to go from grab to cab, right? And this is basically how we solve the answer. We basically just define the base case, solve these sub problems, and then eventually work our way down to solve the bigger problem, right? So now let me show you how we can do this using code, right? So to do this in code, pretty much what I did here is I created a 2-character arrays and a cache array with size of m+1 and n+1. The reason why we do this is because we need to have a room, we need to have a column and a row for empty strings, right? So we first build a first row. For each and every single columns in the first row, it's basically the current index, right? So you can see this is 0, 1, 2, 3, 4. So once we build the first row, we're also gonna build the remaining rows, right? The first column is always going to be the index, right? So just like I mentioned before, like how we got the values here. Basically, we're just going to set that value, and then we're just going to start from here. We're just going to build it all the way to the last row, right? Last row, last column. So basically, for each and every single column from 1 all the way to the end, we check to see if they're the same. If they're the same, we inherit it from the top left, in this case, top left. Otherwise, what we're going to do is that we're going to figure out the minimum value, either replace or delete or insert, right? In this case, here is the top left. This is the left, and this is the, this is the top, and this is the right. So the minimum value out of those 3 plus 1, which should give us the minimum number of operations to take to figure out the current position, right? The current subproblem. So in this case, we just continue until we get to the last, or fill the entire table, and then we're just returning the last cell, right? And you can see this is basically how we solve the problem. And you can see that the time complexity for this one is going to be word 1 times word 2, right? The size of word 1 times size of word 2